I think to start off, this project was really critical for, foundationally, if you will, for additive manufacturing, because the technology was originally built around prototyping, and what the market is saying to us is we need more than prototyping, we need production. And production in the world of manufacturing means repeatability. So the drivers for this project were around repeatability, taking machines that were generally built to do something one time and making sure that we can control them so that time after time after time we can do the exact same thing with these machines. So 2016, 2017, that sort of time frame was when we started thinking about how to create a project around this, how to drive repeatability in one of the most well-known additive techniques, which is fused deposition modeling. So at the time, RP+M had partnered with Stratasys, Lockheed Martin, and the National Institute for Avionics Research and said, how should we go about a problem that historically has not been solved? And we set up a test scheme to try and drive all of the factors which may contribute to non-repeatable conditions, figure out how to control those, and then demonstrate that we had control of those.
So I got to actually see this project kind of all the way through from the start to where we are now. I got to see it from its inception as an American Makes intern, getting to review some of those proposals as part of my assignments. So getting to see some of the initial data and some of the backbone for what would eventually come down the line. Then as intern at Stratasys, I got to see kind of the process variability study that really laid the groundwork for the eventual American Makes project, the ULTEM B-Basis Allowable study. And then I got hired on here, and this was kind of the first main project I got to work on. There's a lot of background work that has to go into this type of process. You can't just take any machine and any material and instantly jump into a qualification. You have to really understand these machines. And so the understanding and having all the background knowledge is really what will facilitate more specifications and qualifications like this.
We are now doing active work for at least half dozen, let's say, aerospace and defense OEMs. That's a completely different relationship than our customers that we've had in the past. What that means is they are auditing us in addition to just placing orders with us. So they come out here and validate that we have all the systems and the controls in place to manufacture parts for them. So for us, it's meant real business opportunities that have kind of transformed the way we work on a daily basis. This is a totally different space now. The applications require more than prototyping, and so what we've demonstrated is that ability to control means the ability to trust what comes out of the machine. And when you're talking about moving into the aerospace and defense community, that's an absolute must. For me, one of the most successful points of the project was really how well the team functioned together. So we had the advantage of knowing a lot of people on the team, but we had probably one of the most cohesive funded projects that I've ever worked on. I am quite convinced that none of that science and none of that data would ever have been generated without a funding entity like American Makes that was able to pull it together.